Hi. Yes. So yeah, the topic on the schedule was like too long to actually fit on the slide, so I made it a bit shorter. But what I'm actually going to talk about. So basically, I'm going to concentrate on our experience in building practical MPC implementations. We have been like in the game for quite some time now. So first, I'm going to give you an overview of our current offering, then introduce some like problems that we see with it and where we want to go, and how we see that it would be actually beneficial for other MPC vendors as well. And as an example, I'll going to outline our roadmap of integrating with Carbine Stack as an example. So okay, before we can go on, since this is a very mixed audience, MPC can mean a lot of different things for different people here. So this is what I mean by MPC for us. So basically, we are using this kind of computation outsourcing model. So we mainly use secure multi-party computation technology for outsourcing computations. So for example, this is like one of the real deployments, one of the biggest in sense of data volume actually that we have had. So on the left side, you can see two data owners. There can be any number of data owners. They have their private data sets. And what they do when they want to compute something like from the union of their data sets, then they each on-premise secret share their data and upload it, or distribute the shares among the computation parties. In this case, there are 3 computation parties shown in the middle. As you know, they have to be independent, otherwise MPC wouldn't really work. But there are, of course, different like security models. And then on the right side, there are 1 or more authorized parties who can actually make queries to the system and then get the like agreed upon output. So of course they can't like query anything that they can think of. They can only query like primitives or functions or applications that have been previously agreed upon also with the data owners. So for us, it started like the product we have, ShareMind MPC. Its development started in 2007. So that's why I say we have been in the game for quite some time. Here are some of the like achievements or developments. I won't go through all of them, but like some of the most like important or dear to me are like the one in 2011. So we used ShareMind MPC for benchmarking financial data in Estonia. The data set was really, really small, but as far as we know, it was the first MPC deployment with real data where the computation actually took place over public internet. Before that, there had been this Danish sugar beet auction, but this was done over local Wi-Fi. So the next one is 2015, which is actually the deployment here. So there we put together tax data and education data to answer questions like whether IT students in Estonia are dropping out of their studies because like IT companies are like hiring them early on and then they don't have time or motivation to finish their studies. So that was the hypothesis. The answer is no, by the way, according to this study. But anyway, we got like 600,000 education records and over 10 million tax records from the like respective ministries. And what makes this analysis special, or this deployment special, is that the analysis wasn't actually done by us, like cryptographers, but rather professional statisticians. And for them, we implemented this privacy preserving version of R, the statistical analysis tool that is like R is open source. So we basically took the language of R that the statisticians already knew about, and then we like implemented a new backend so that everything that the statistician would write in R, so all of the commands actually were implemented on the backend using MPC. So that's where we got this like another component of ours that is called RMind. And finally, I'd like to point out the most recent deployment from the end of last year. So where ShareMind MPC was used to do this multi-center clinical trial or data analysis concerning tumor treatment radiotherapy data between Ludwig Maximilian University in Munich and Gemelli Hospital in Rome. And in a like this deployment is in a sense a landmark for us because this was a really good customer, because the customer just from somewhere heard about us and just came to us with a like very specific wish that they want to use ShareMind MPC with this RMind statistical analysis tool. They just bought the license. We helped with some like basic customer support, and they did everything else themselves, like getting the other computation parties, deploying it on servers, doing all of the DPIAs and everything that is requested under GDPR. So everything. We were just a technology provider, and this is the ideal case for us. So finally, it has come true after like 15 years that we can actually like provide a box product and just provide support. So yeah, it took some time, and hopefully there will be some results published about this. Anyway, so it has been more than 15 years developing this, and all of those deployments except the first one were actually using this product of us that we call ShareMind Application Server. So what is ShareMind Application Server? So this is the basic architecture here. So in the heart of it is actually the like secure computing engine. This is actually the like MPC protocol implementations. And we actually like the MPC protocols there are interchangeable. So we have this concept of protection domain. So basically, you know that there are different types of secret sharing. There is like secure secret sharing, additive secret sharing. You can like do like verified secret sharing, whatever. And then there are like different number of parties. There are different like security models, active versus passive security, and so on. So, and if you take one instantiation of it, for example, like free computing parties, additive secret sharing, and passive security, then that would be one protection domain for us. And ShareMind Application Server supports like many of those. You can like swap them out. So this shared free P here is exactly what I told: additive secret sharing, free party, passive security. This is the most advanced one for us. We are also working on actively secure protocol suites. So yeah, this is interchangeable. And then we have this domain-specific language called Secrecy, and it's open source standard library that you can write your privacy preserving applications in. And you don't have to be a cryptographer to do that because it hides all the MPC complexity. And of course, those programs, for example, want to store data. So you can choose between key value database or tabular database that is really useful for data analytics. And of course, on top of that, you have to do some access control. So only authorized users can like access authorized data tables with like those programs that are deployed on the server that are authorized to specific persons. And the output then goes to also specific authorized users only. On the client side, you can choose from one of the ready-made applications. For example, most of the data owners use CSV importer to turn their local CSV into like basically secret shared form and then distribute it among the computation parties. If you want to do data analytics, then RMind with our language is there for you. Or you can build custom applications with, well, in C, C++, Haskell, Java, or if you want to do a web-based, for example, questionnaire form, you can do it in JavaScript. Okay, so that's basically our offering at the moment. And it's been really cool developing it. However, well, there are pros and cons about it. One thing that we really like about it, of course, is that, well, we have stick with it for over 10 years. It's practical, it's battle tested, it works. So if somebody wants it, we can deliver it the next day, basically. It's also modular. As you can see, there are like different components. You can switch them out. You can switch between protection domains with different security guarantees. That's fine. And we have built a lot of like existing tool chains around it. For example, we have a special tool chain and actually a special language to like write our protocol implementations in that does like machine optimization and also like security checking. And we have this like data analytics workflow. However, the main problem is that the thing is huge, so it encompasses everything. So we would like to concentrate on what we think we are best at, which is implementing MPC protocols that we call protection domains, basically. And we really love the secrecy language and its standard library. So everybody could write privacy-preserving applications. And on top of that, like I said, we have built extensive data analytics capabilities. So we also like that part. However, what we have to deal with in addition to this is like, for example, user management. We have to do user authentication, authorization. We have to do those access policies and everything for it to be actually like deployable in practice, because you can't deploy something that is like open for everybody when there's real data in it. So we have to do task management, because you can actually run several secrecy programs in parallel on ShareMind application server. And we actually have our own implementation of the network library, because at the time of building this, none was good enough. So we actually took TCP sockets and built everything on top of it with like stream multiplexing and everything. And maintaining all of those components is becoming increasingly difficult, because, well, like I said, we would actually like to concentrate on what we like to do, but we really don't care that much about task management or user management. And also, since ShareMind MPC has academic background, then there are some funny features that look really cool on paper. For example, I introduced the concept of protection domains. But what is maybe not apparent is that you can actually use several protection domains in parallel in the same program. So in the same program, you could actually use like data that is secret shared between 3 parties in passive model, and then also 2 parties out of those 3, for example, in active models. And then you can have specialized resharing protocols that actually convert from one domain to the other. It's really cool. Nobody has ever used it in production, but it's there. And then finally, well, we have like components being different packages, and we have this like delivery system in place. However, we would like to have more like this state-of-the-art deployment mechanisms, for example, infrastructure as code principles that are like quite like normal today, considered normal today. And also, while you can build like scalability solutions on top of it, the scalability is not built into the application server. So with that, we went back to the Blackboard like about a year ago and took it apart into components, basically, and thought that how we could like put it back together so it makes more sense and it's more maintainable. And we came up with a solution that it's a good idea to like separate MPC runtime from MPC platform. And probably it's not like a new concept or anything. It's just that for us, it took some time, actually. So MPC runtime would be like the core of the system. So this is the component that actually executes MPC protocols, and only the minimal amount of things that are related to it. For example, you have to have some code that describes what protocols are actually executed in what order. So you have to have some kind of like language to express this. And then, of course, since this is a distributed system, you need some like network connections to the other parties, computing parties, to actually exchange messages. But this is it. This would be the runtime. And then we can move everything else to the platform. And this everything else is like everything that has like interfaces with clients, and also all of the facilities that like application would like to use. For example, storage, persistent storage. And then if we are talking about active security, then pre-computation, these access policies, and so on. And also that platform could coordinate like discovery and so basically like finding other computation nodes and so on. So okay, this is fine. But if we just take our like current solution and split it into platform and runtime, then this is not enough, because we still have to maintain it. If we still have to maintain both parts, then this is not really ideal, because this is a burden. So it would be really cool if somebody else took this platform maintenance out of our hands. Luckily, after some research, we found Carbon Stack. And there might be others, of course. But Carbon Stack's like offering or idea looked promising to us. So basically what it is, it's an open source MPC platform built on Kubernetes. So there you have like state-of-the-art technologies already. So currently it's developed mainly by Bosch Research, but they are like developing it openly, transparently, and they actually wanted to turn it into like a real like collaboration project. So they have some contributors also, us included, and basically it uses cloud native design principles, and it uses a bunch of microservices. For example, so on the figure here you can see basically MPC deployment with two parties. Each party has those microservices. Ephemeral is the service that actually like invokes the MPC runtime. So basically this is given this like code, and it invokes it and then just goes away. And then there are supporting services, for example, Amphora for long-time share storage. Klushko is computing basically correlated randomness, like beaver triples and other type of correlated randomness. And Castor is for storing those correlated random values. And so here is how we plan to, or we are actually like integrating with Carbon Stack. So by default, Carbon Stack uses MP speeds as their MPC runtime, because MP speeds is open source. And it has this task as a process model, basically. So this ephemeral microservice is just giving this like code or like command that run this MPC process now, then it forks a new process that runs MP speeds, that is given a code, and then it runs it, and that's it. So this is like it forks a new process, and this MPC runtime, this process, this only runs a single MPC application, and that's it. So there is like all the task management and everything, it happens on the platform side, like we would like to. And all of the facilities, these are like accessed through this predefined runtime interface. And what we are currently doing, we are like repackaging ShareMind MPC and also introducing code changes in Carbon Stack to actually provide ShareMind MPC as an alternative MPC runtime in Carbon Stack. So, but this is actually not as trivial as it may sound, because Carbon Stack is, as a project, is in its infancy actually. So it is missing a lot of features. For example, it doesn't have authorization, it doesn't have authentication. It at the moment, like code to be run under MPC is given by the client, which of course can't happen in production. So we actually lose all of those features compared to our current offering, but still we see that Carbon Stack as an idea is worth it. So we chose to maybe help them to bring those features to life and make this like generic platform better in that sense. So work is ongoing there. So yeah, for us, the idea in the integration is that we can leave the difficult distributed systems part to the experts, because the Carbon Stack team in Bosch Research mainly consists of distributed systems people, or actually the main players there are distributed systems people, and by using platform like Carbon Stack, we can get this like elasticity and scalability of cloud for free, basically. We also get infrastructure as code for free almost. And on our side, what we can contribute are battle-tested MPC protocols that are actually ready for production. We are happy to also bring our secrecy language with these libraries. We support with open source components, both into the Carbon Stack code base and also next to it, some supporting components. For example, Carbon Stack only has key value database. We are interested in tabular database because we really care about data analytics workflows. So we are actually now finishing building this like tabular database that interfaces with Carbon Stack, that hopefully will be open sourced soon. And we can bring some experience because, well, we have some experience in deployment. Okay, so but the title of this talk was very promising, that we would like to bring down costs for everybody else. And I would like to point out that if you're like a MPC vendor, like building MPC solution that, for example, is suitable for this kind of data analytics deployment, then you might actually want to think about integrating with a generic platform like this. In the long run, it doesn't have to be Carbon Stack in particular, but just the idea that maybe there's like a common interface that everybody speaks that takes care of the like general supporting functions, so we can concentrate on actually building better and faster and performant MPC protocols and implementations. Maybe that like makes sense to somebody else also. And it allows actually us and everybody else to build like real real-world deployments that that make use of those platforms. So you can switch out the underlying MPC runtime because they all talk the same interface. And for example, currently we are building this MPC as a service solution for Eurostat, European Statistical Agency. It's in analysis phase currently, but there actually a hard requirement is that the data plane, the actual MPC backend has to be swappable. So it makes total sense to actually like build it on something similar, like put in place those like interfaces that all of the different MPC backends have to like agree upon. So they will be really swappable, for example, because MPC like evolves, MPC offerings evolve so fast that tomorrow there might be something more performant, more secure, whatever. So yeah, that's I guess something that we, coming from like more than 10 years experience, would like also others to consider, because programming new components is cool, but maintaining them is maybe not so cool. But then taking a step back, then actually when we took this ShareMind MPC apart into components, then we also realized that this MPC runtime that I currently talked about is not actually the minimal part that one can deploy. So if you just take this execute MPC protocols out of the runtime, then you can also do something with this. And we call it protocol core, which basically just keeps the like bare MPC protocol implementations on syscall levels. And this kind of component can be used to build what we call like embedded MPC deployments. For example, if you need it for, I don't know, asset management, for example, like really integrated low-level specific one-off things, then that might make sense. So in this case, what you have is that you talk directly to MPC, you actually call directly MPC protocols. For example, you just say that let's now run these multiplication protocols, and you give it 2 secret-shared vectors, or 2 vectors of with secret shares. And it just gives you like 1 vector of secret shares back that represents the product of those. And you have to bring in your own network library, and you have to bring in your own higher level language if you wanted to. So you basically, if you wanted to, you could build your own MPC runtime on top of that. But if you really want to do like embedded, for example, 2-party client server MPC stuff, then you basically could on that level. Anyway, that was a little bit of sidetrack. So if this platform and runtime split sparked some interest, and you would like to have a say in where Carbine Stack, for example, as a platform goes, then you can join their like discussion on their GitHub. So now I'm advertising somebody else's product, but anyway, we believe in that. So thank you.
Are there any questions? No questions? Okay, all right.
Okay, thanks.
Thank you so much.